Hey, what's up, guys? Today we're looking at measuring and constructing segments. And before we get in that, we're going to have to get into some undefined terms of geometry. And it's really, we can't define them in any other, by using other figures. They're just the basic building blocks of geometry. So first off, we have a point. And we label them with letters. And it just has, it's a location, has no size, and it's just represented by a dot. Next is and that's just a point. Next we have a line, and lines are just a straight path, and it goes on forever when it's has the arrows at the end, and we will label them with, most of the time, cursive letters. So like this one, we call it line L. And we also can put points such as X and Y there, and we can label this also as line XY. And if it goes on forever, we're going like that. Or it can be YX, the other way around. Next is we have a plane, and a plane has no thickness because we're dealing with two dimensions. It extends forever, and it'd be something like this. Like plane. It's imagine that extending forever, but it's just we can't draw extending forever. And then there'll be points, maybe even lines inside of it, but that's just how, like the XY coordinate plane, like there's an X plane and a Y. That's how the best way to represent it. And we use script letters to do the plane, so like R. So that would be plane R. Or we can write that as plane ABC because they're the points ABC in there. If there are no points, we just call it plane R. Next is we have line segments. And I'll scroll back up just so you can, if you're taking notes with me. Segments they have two endpoints. They don't go on forever. And so like we'll have point AB, and we denote that as line AB, the line above it, AB. Endpoints are the points at the end of those line segments. So these A and B would be endpoints. So that would be an endpoint, and this would be an endpoint. Array has an endpoint, but then it extends forever in one direction. So array would be something like this. Where we have R is the endpoint, and then it goes through S, but then it extends on forever after S. So it would look, how we denote that is RS and then a line with one arrow, ray RS. And then opposite rays are where they can share a common endpoint and then they go each way. So like if R, I guess I can write it, opposite rays where they share an endpoint, and so like E would be here, and then they have F and then G. So they share endpoints, and we'd write it the same way we write the other one. So that's just a quick crash course in what we're talking about, so we're not confused. So let's get into that. And by quick, I mean a 4-minute and 20-second crash course. All right. So we need to find distance somehow on these segments or just these lines. And so if we have the number line is an example, and it goes on forever to infinity in both ways, we pick points in the middle and use them. So if we had A and B here, How we'd find the distance between the two is we'd denote that as line AB. We want to find the length. The length will equal, and we're going to, sorry, I forgot to label our line AB. And the length will be denoted by, and one thing to remember, length is always positive. So we have to do absolute value. That makes it always positive. And then we can either do A minus B or B minus A. Okay? So that's either or, because it's going to come out positive because you have the absolute value. So let's say that we have our number line and we're dealing with the areas of -1, 0, 1, and 2. And we want to know the distance between E and F. So, line EF is going to equal, and we can do it two ways. As long as we have our absolute value, we can either do -1 minus 2, which will equal -3 absolute value, which is 3, or we can do absolute value of 2 minus -1, which that'll turn to positive, and we'll get absolute value of 3, which is 3. So the distance between the 3. And you can easily count, but when you get to bigger numbers, we don't want to just count. Another quick term to know is when we have congruent segments, we mark them with ticks. They're called tick marks. And that is definitely not to scale, I'm sorry. So we have P, Q, and then R, S. If they're denoted in the middle with a tick mark, which will look like that, and most of the time they'll be like red in your book, they'll be a different color, then you know that they're congruent segments and you can go accordingly. So congruent segments, they'll either tell you, or there is a term called a midpoint, where it's in the middle. And when you divide something in the middle, just thinking about it, both sides are equal. When you put something in the middle, both sides are equal. So let's say we have a line there. Let me get rid of that. And we have AB, or AC, and then you're told that B is the midpoint. So if it's the midpoint, if it'll write for me. So you know that B is the midpoint. So if B is the midpoint, what do we know? That A and B is congruent and B and C is congruent because it divided it in half. So with that knowledge, let's say that they're labeled. Let's say this has a length of 5x and this has a length of 3x plus 4. You know it was divided in half, so both sides are equal, so you can set them equal and then use your algebra skills to solve for x. So 5x equals 3x plus 4. Subtract 3x to both sides. We'll get 2x equals 4. Divide by 2, divide by 2. Come on. And x will equal 2. And so they'll do that. They'll just test your skills by putting algebra with it. But let's look at let's actually, before we look at an application, let's look at one more way that they'll have you use algebra. And it's not involving midpoints. Okay. So if they give you a segment that looks like this, and it's labeled R, ST. And they tell you that R to S is 2x plus 7, and S to T is 28, and the whole thing is 4x. We use something called the segment addition postulate, where we know that RS, the distance of RS, plus ST, which are two different segments, will equal, will equal RT. So that's the segment addition postulate. So we're going to use that and just plug in. So RS is 2x plus 7. Come on. So ST is 28. So we're going to plug that in. If it loads. Computer's being slow today. And that's going to equal the whole thing, which is 4x. So, if that equals 4x, we can solve this with our algebra skills. 2x plus 7 plus 28, we can combine like terms, and we're going to get 2x plus 35 equals 4x. We'll subtract 2x to the other side. We're going to get 35 equals 2x. And we'll divide by 2 on each side. And we're going to get that 17.5 equals x. So that is, we can plug that back in to find the distance of each segment. So if you wanted to know the distance of RT, the whole thing, we would plug 17.5 in for x, and we'd get 4 times 17.5, which would be 70. So that's what you do. You'd find x and solve it in there. So let's look at one last application of this where we kind of combine all we've learned. And I gotta hurry, I'm running out of time on my video. It would help if my computer wasn't so slow today. So let's say that you are on a run or a race, and you have, come on computer, 2 kilometers left in your race. And you're here. You know a drink station is here. It looks like an ice cream cone, but you know that a first aid station is here, and you know another drink station is here. I'm sorry about my dog barking. So, you know that from you to the drink station, you just saw a sign, is 365 meters. You also know that the first aid station divides the 2 drink stations in half. It's the midpoint. So you know that these 2 segments are equal. So to do that, we're going to convert that to 2,000 meters. So that's the whole thing. So then we're going to get 365 plus x, this whole segment in here. So it's 365 plus the 2 drink stations distance would be that. So once we subtract, and I'm going to have to hurry because I'm almost out of time, is x will equal 1635. Now, we want to know how far you are from the first aid station. Because pulled a hammy, I don't know. So that is going to be half of the distance between the 2 drink stations. So we'll divide this by 2, and we'll get 817.5. So you are 365 plus 817.5 meters. So you are a total of 1187.5 meters from the first aid. So thank you for watching. Sorry this was a bit choppy. I'm going to restart my computer. But leave some comments, check by the website, and thank you for watching.